Hey, welcome. This is a quick showcase of my proof of concept, physics and AI sandbox. It's isomorphic, so it can run in the browser and natively using Jolt, WebGPU, Vulkan, and my custom AI framework Paragon. Let's walk through and what it can do. So for the first scene, we're just going to show what it can do. You can actually load the entire thing, the whole scene via JSON, and that includes AI controllers, automated actions, and other things like that. So right now, we're pressing play. The green ball can fall and just rolls forward, and then just pulses jumping, and then you can move that object. And actually you can see fall and then start from the new height. Next I tested scene generation, so I just went to a Grok or an AI, and I wanted to make it really busy, you know what I mean, and change all the different colors. I'm testing multiple different shapes as well, what's that pink thing over there, and the donut over there and the cylinder, and that got some weird behavior going in the middle, so not sure what it generated for that. So that's quite interesting. And I'm just gonna rotate this to change the trajectory of things. So interestingly, because we built everything from the ground up, from first principles, I suppose, we can actually change what type of implementation of the Jolt physics engine. So we can compare the WebAssembly version versus the JavaScript implementation. And obviously the WebAssembly just performs so much better. But there's you want the JavaScript one for low, computing, low memory usage, but the WebAssembly version for high fidelity. So now, what if we want to import bulk objects? Well, I wanted to make that pyramid as you saw for before. So right now we imported the pyramid, but it can't actually fall, and so we need to make all those different individual cubes have physics. I think there's a couple hundred there. As you can see, the actual the cube automatically rotates, and the AI just goes off that green sphere. Oh, it's really zooming around, isn't it? Where'd it go? So, automated object motion. So, how did we set up that cube to actually automatically keep spinning? And I think it's jumping as well. So we can create an AI controller, and these controllers could be three different things. It could be just an automated thing, just do a simple pattern, so we can actually just keep rotating or move in a specific direction, impulse, angular, whatever. Or it could be a player. So the player could be facilitating whatever controls that you set up to be, or that you can actually switch it to to be the actual neural network as well. So there we go, the cube spinning, and it hits that red cube off. And I think we moved it into the wall because I thought that was pretty funny. Oh, we're just changing the actual position and stuff for the velocity. Just, yeah. Ah, there we go. I'm moving it now. So we can actually shape or potentially shape the AI's behavior based on player data. And now this is just a proof of concept, so we actually just getting here was actually mind-blowing. And that, so we want to play the scene and hit record. So every action the player takes, it actually it puts it into a time series, and then we're just gonna move it around, see what it does. You can choose what objects it's recording. So it could. So right now it's just monitoring the cube, the red cube and the green sphere, and that. So the AI controller can actually watch one thing and then control another. So nothing's like locked in. That's the whole point. And that, so we can actually stop and export the actual data. Then we can actually re-import it back in, and then we can just train the actual AI model. And that, there wasn't much data because it's only pulsating, like I think it's like 2 actions per second or something like that. And then we want to switch it to the AI, and then when we hit run, the AI will be controlling the sphere, and there we go. That's how we got the AI to actually just do that. So next we're testing the physics constraints, and I generated like a dog. I think it looks more like a bear, really, but I think this has actually got fixed constraints. Lastly, we've got multi-server watching and that. So we've loaded in a file which multiple different sort of physics and servers are happening in the background, and that. So it's technically called, I guess, multi-server monitoring and layer blending. So we can actually watch multiple different servers and actually change the opacity. So if you're trying to get something to walk, maybe in the future, and you have like multiple different sort of environments running at the same time, you can easily overlay them and actually say, hey, this is where each one is up to, and actually change the opacity of each. So that's pretty interesting. So that's my current proof of concept, cross-platform physics sandbox where AI can be trained directly from play. There's still a ton of things to do, but this is just the foundation. Thanks for watching.